Okay. Um, so to all of you slackers out there who are watching this, because you weren't there, um, this class does meet Monday, Wednesday, and Friday every week of a semester. So don't pull this again until Good Friday, and it's okay. All right. So one side comment I wanted to make, but I'll probably have to make it again when we come back, so that everybody will be here, because you're all. It's advisement season. I've been doing advisements for several of my own advisees, so I imagine you all are doing the same. Of course, that invites me to do a shameless plug for my upper level class. So I'll be teaching 460 in the fall and 461 in the spring. That is the numerical analysis sequence, which for math majors, 460 satisfies the technology requirement, and or if you're satisfying it a different way, it can be used as an elective.
Is it required for licensure?
It is not required, but it can be used because you have to take a couple upper level electives, so it could be used for that. I tend to get a number of licensure majors too, and it's certainly more of upper level classes we have. One that's more relevant to real world math, and I certainly try to make it that way. So come join us; it'll be fun. And let's see. It's kind of a mix of things. There's some problems that involve proofs, but there's some involve there's some computer programming component to it. But that's what really makes it more relevant. Also, not just for math majors, polymer science majors might find it interesting. I know there's at least one or two classes in polymer science that cover similar things. So if you want more of a background, maybe that's something you can talk to your advisor, Dr. Broadhead, about. So hopefully some of you will be there. Okay, now I started talking about non-homogeneous second-order linear equations of constant coefficients at the end of last time. I did an example, and I realized right after all of you left that I made a mistake at the end of the example. So I recorded another clip, like in the 30 seconds or so, at the end of a video where I fixed it. So I would encourage you to check that out. So what we're going to do today, and then also when we come back after break, is spend a lot more time on non-homogeneous equations. And with that in mind, I should mention that I go into a lot of detail with this in my notes, where I derive the solutions from linear algebra point of view, etc. I wish I had time to go into that level of detail here in class, but we don't. Although some of you might like it better that way, to not, and just cut straight to a formula. So I kind of catering to the approach that students prefer more. But the way we're going to arrive at the kind of solution techniques that you're going to use on a test, I have a group activity in mind, which is one reason why I'm particularly cheesed off that nearly half of you aren't here. But that's okay. You just work with whoever is here. All right, so pass these around. Yeah. So the way this will work, well, we have, in each row of tables, we have 2 or 3 people. So you're just going to, I guess you're working solo, or if you really want to move up, you can. All right. Once they're handed out, I'll explain the directions. I guess this is my way of doing my own homework for this active learning thing that I'm taking part in.
Is this being graded?
Well, yes and no. I'll explain. Is it being graded for what you do today? No. So you're not on the spot to that degree. Okay. Yeah. All right. So here's how this is going to work. First, we're only going to look at the problems on the front, where you're given 5 non-homogeneous differential equations with different choices of a right-hand side function g of t, and in each case you're given 3 forms that the particular solution that I explained last time could take. So I mentioned last time there's a homogeneous solution, which we're not dealing with right now, plus a particular solution. So right now we don't care about any initial conditions. You're just trying to find some function that satisfies the differential equation as given. So here's the idea. One of these forms, of the 3 that you're given in each case, is the right one. So discuss with the people in your group, the 1 or 2 people, which do you think is the best one that works. And if you think that something is not going to work, go ahead and skip it. But you should be prepared to explain to your fellow group members why you don't think it's going to work. Like if you plug this in, you might be able to get an idea, here's what the derivative is going to look like and what kind of function you're going to get. So some of these will have some interesting wrinkles to them. And I'm going to, so the idea is, I don't want you divvying up the 5 among yourselves and working individually. Work on each one together. Let's aim for 15 minutes, and we'll see how things go. So, go. Okay.
I think 1 is C. But I might be completely wrong because I usually don't look at this except for a week before an exam.
Okay, so in these last 10 minutes that we have, so first, for those of you who weren't here today and are watching, for those who were here are getting a little bonus that you are deprived of, and you're getting penalized for not being here as usual. So, okay, better not say anything more. I don't want to be profane on video. But yes, I am bad ticked. What I was going to do was, because I said 15 minutes, we've gone a lot longer than that, and I decided to let it go longer. And I was going to do like a mini lecture on the topic and then have you guys resume. But with half the class not here, I'm not going to do that. That'll be postponed until the Monday after break when all of you had better be here. Okay, so the question, how many of you successfully completed the 3rd one? Okay, which form was the correct one?
Probably C.
B. I got B.
I got B.
The answer is B. Problems 2 and 3 were chosen deliberately because they seem like the same thing, but they're not. And the reason for that, I'll make it clear after break, is that in number 3, if you just try plain old e to the 2t, that's a solution of a homogeneous equation. You plug e to the 2t into the left side, you're just going to get 0. Because the roots of your characteristic equation are 1 and 2. Whereas in number 2, 3 is not a root of a characteristic equation. So it's not just a matter of what functions on the right-hand side. What's happening on the left side of a homogeneous solution is also relevant. And it's also relevant in the interplay between problems 4 and 5. What works for 4 does not work for 5. And I'll explain more about that on Monday. Okay, now, one thing I want to take a couple minutes to discuss is, so I'm going to read a part of the directions here. For each of the following equations, substitute each of the given functions, y, p of t, into the equation, and try to find values of the arbitrary constants that satisfy the equation. And it's become evident that while in my highly experienced mathematician brain those directions seem clear enough, evidently they were not. So this is something that I've learned from giving this activity. And that it evidently was necessary for me to go through the motions here on the board on a couple of these things in order to get you guys moving along more. And so that's pretty eye-opening. Also a cause for concern because these are the kind of directions that you would get, like for instance, exercises from a textbook, problems on a test. Now, this is one reason why I give a practice test, and we go through it so that whatever directions are given on the real test won't throw you off as much. But my point is, whatever language I've used here, like on the directions, substitute each of the given functions into the equation. Try to find values that satisfy the equation. That's something that, especially those of you who are math majors, or really anybody in this class, you need to understand what that means. What it means for something to satisfy an equation. That you get total equality on the left and right. And while that you're accustomed to that for maybe equations involving just numbers or maybe a single variable, here we have more than that. We have functions of t that you need to match on the left and right. It doesn't change the meaning. So what I'd like you to do is something to think about, now that you've gone through a few of these things, is now go back to the directions. And do you see what I meant by that now? And because these are that's how directions will always go. That and also if we are going to do various activities like this in the future, I think what always happens, and really this is one of the main challenges of any class like this, is that there really is a language barrier. That I'm giving instructions in a way that I know how because I have to be precise. But that still doesn't mean it is anything more than gibberish to the audience. And that's why it's also important for questions to be asked sooner rather than later to try to bridge that language barrier. So, yes?
Can you work that 3B, whatever it is?
3B. Okay. Now, while I'm doing this, the last comment I want to make is on the back. I thought after you guys do this and then I lecture for a little while, and when we go back to it, here's some problems to practice with. I chose the problems from the textbook for problem set 10. So this is problem set 10 on the back. That it's not due for a while. Well, plus there's reading questions that are on the site. But so I figure that way, this is at least indirectly counts for a grade. You're asking about 3B?
Yeah.
Okay. So your proposed solution is constant t e to the 2t. So then you take the derivatives, and because of the t, you need the product rule.
Yes.
So you need c naught 2t e to the 2t plus e to the 2t. And then similar for the second derivative. So here you need to use the product rule again. So that's 4t e to the 2t plus 2e to the 2t plus 2e to the 2t again. So then what happens is you put all these together, and what you have is y double prime. And I'm going to factor out e to the 2t because it appears in everything. So that's y double prime minus 3y prime plus 2y. And that is matched up against e to the 2t. And
Isn't that supposed to be C-O-T?
Yes. Okay. Now, what ends up happening is okay. Now, okay. So something strange is going on. Okay. So now I need to rearrange this. All right, so I have e to the 2t on the left side. On the right side, I have 4 minus 6 plus 2 t e to the 2t. So I grouped all the t e to the 2t terms together. Plus, and then anything not involving a t, c naught 4 minus 3 e to the 2t equals e to the 2t. What happens over here though? Everything cancels out.
Wait, why do you have two fours?
4t e to the 2t, and then 4 e to the 2t. Oh, from here? Two of them came from the product rule from this, and the other two came from that. So now, this has to be satisfied. Well, it turns out c naught equals 1 will do it. Yeah. So, whereas if I just plug e to the 2t, I would have got 0 on the left side. I guess I should have shown that to whoever's watching at home, even though I'm still pissed at them. Okay.
Part of their thing.
Yeah. Yes. Okay. So, lower delay compared to your classmates. Enjoy your break. You too. Okay. I'll be in California, so yes, I will.
So don't go too crazy.
I'll try.